This video is on density and molar mass using the ideal gas law. So without opening it, could you identify a gas inside a balloon? You can. You just need to use the ideal gas law. So of the balloon, we would know the pressure, which would be atmospheric pressure. We would know the temperature of the room. We would know the volume of the balloon, but we would need to find the moles of gas in the balloon. Once we know the moles of gas, we could figure out the molar mass of the gas inside the balloon, and from there we could figure out what gas is in the balloon. So to do this, we need to figure out both density and molar mass from the ideal gas law. So we need to do a little deriving here. I know that density is equal to mass divided by volume. Mass I can get from moles, and volume I can get from my ideal gas law, PV equals nRT. So my ideal gas law, moles is how I can get mass. I know that if I want moles, I could take the mass divided by the molecular weight, or molar mass. And we're going to call molecular weight capital M subscript W for molecular weight. So plugging in mass divided by molecular weight for moles in my ideal gas law equation, I have PV is equal to mass divided by my molecular weight times RT. Now if I want density, density is mass divided by volume. So by subbing in for moles, my mass divided by molecular weight, I can now manipulate this equation to get mass divided by volume, which is density. So first I go ahead and distribute my molecular weight over. So I have pressure times volume times my molecular weight is equal to my mass times R and T. I want mass divided by volume, so I divide RT both sides, and then I bring volume over. So P times MW divided by RT is equal to mass over volume. And mass over volume is density. So I could say that density, which we call D, is equal to my pressure times the molecular weight of my gas divided by R, my gas law constant, and the temperature. So from this new equation, which is a manipulation of our ideal gas law, I can get density and molecular weight of a gas as long as I know my other variables about it. So what about the molecular weight or molar mass of the gas? Well, I would just rewrite this. So you can figure out the molecular weight of a gas using this new formula, rearranging for molecular weight. So molecular weight is dRT over P, or dirt over P. Or we can use the ideal gas law and just do some division at the end to figure it out. So we'll do it both ways. So in my example, I have a 15-liter balloon at STP with a density of 1.96 grams per liter. What's the molecular weight of the gas? So if you'd like to memorize your new equation or derive your new equation each time, you can do that. Pulling out our variables, we have a 15-liter balloon at STP, so my temperature is 273 Kelvin, and my pressure is 1 atmosphere. And then R is our gas law constant, 0.08205 atmosphere liters per mole Kelvin. Okay. And I also know that I have a density of 1.96 grams per liter. To figure out molecular weight, that's density times R times T divided by P. So I just plug in density RT over P, which is my 1.96 times my 0.08205 times my temperature divided by my pressure gives me 44 grams per mole as my molar mass, and then I know that that is carbon dioxide because we use it a lot and we find that out a lot. Okay, so I remember that. So you could do that and memorize it, or if you're like me, you don't want to memorize another equation, you can just use some dimensional analysis and the ideal gas law to figure it out. So, or I take what I'm given, my density, which I know is 1.96 grams per 1 liter. So in this case, I'm going to look at 1 liter of gas because I know that it weighs 1.96 grams. So my volume is 1 liter for my density equation. I'm still at STP, so my pressure is 1 atmosphere, my temperature is 273 Kelvin, and my R is still the same. Okay. And if I want molecular weight is grams per moles. I know my grams already. My density tells me I have 1.96 grams per 1 liter. So this I know. It's 1.96. What I don't know is my moles. So I don't know how many moles this goes with, so I need to find this. And to do that, I'll use my ideal gas law, using my 1 liter for my density. So moles is equal to PV over RT. So I plug in my 1 atmosphere, my 1 liter, and I get 0.0446 moles of my gas. So this I can plug in here. So my molecular weight is equal to my grams divided by my moles. For my grams is my 1.96 divided by my moles with my ideal gas law, 0.0446. And when I do that, I also get 44 grams per mole, which I know is carbon dioxide. So it doesn't matter which way you choose to do it. I like this way because it's one less equation to memorize, and I know what my units are, and I can use my units in what I know and don't know to figure that out. But if you'd rather memorize another equation or derive that equation and do it that way, that's fine too. The important part is we're showing our work using our units and calculating the correct answer.